one of the points of this talk is that Objective-C is becoming more and more like Ruby all the time. So maybe we should consider just jumping ahead a little bit and using a better language. And Ruby could be one of those languages. So let's go back to slide 2 and take a look at what's changed and how that compares to Ruby. So memory management is already garbage collected in Ruby. Ruby has always had synthesized properties. It uses dot notation all the time. You don't have to use braces. Decide which one you want to use. And it will synthesize getters and setters for those with the adder accessor statements. Ruby has for loops and iterators and all kinds of stuff up the wazoo and blocks that you can use to do your own custom control structures. With class extensions, Ruby lets you put everything in one file, so you don't need a header file like you do in Objective-C. And they have keywords to declare things private and protected. Blocks are built into Ruby. You can use blocks everywhere, pass them to methods that don't even expect them. You can yield the blocks, all kinds of stuff, support for blocks. Whereas Objective-C just has dictionaries and hashes, Ruby has regular expressions, numbers are objects. By default, everything's in objects. It has ranges as well. And also, Ruby has modules that we talked about further, and you can use them themselves, and you can even include modules into your objects to do a form of multiple inheritance. So, here's some more advantages. To me, the Ruby syntax is more concise. There's less noise in the code, no semicolons, everything's dot notation, it's consistent. As we talked about, there's more built-in types like regular expressions and numbers are objects and ranges. I mentioned mix-ins with modules for a form of multiple inheritance. Metaprogramming is a thing you see in Ruby all the time. Objective-C, with its runtime, you can do a lot of metaprogramming with it and create methods at runtime and classes, but no one really does it because it's a low-level code and it takes a lot of code to get that done. But in Ruby, it's done all the time. Just take a look at the Rails framework for the power that metaprogramming can give you. And Ruby, being an open source project, has a lot of open source libraries. That's kind of changed lately with iOS. There's a lot of open source libraries for Objective-C as well. So I wanted to show some examples of Objective-C versus Ruby code. So at the top here we have, we're iterating through an array and printing out its contents. So you see we have a big long method call. We have braces and semicolons. We've got our weird block syntax. We've got our format specifiers and our NSLog statement. So there's a lot of noise there, as well as the length of the code it's wrapping around the screen. We're down below, we have the Ruby version of that. A lot cleaner, a lot less code. Really the only noise is the interpolation of the strings, and even that is simpler than the Objective-C format specifiers. Here's another example. Here we are replacing all the characters that are not letters and digits and underscores with an underscore. So at the top we have the Objective-C code. Again, a big long method name. We give it a string for our regular expression pattern, the string to replace it with, and then we still have to tell it that we're doing a regular expression search, and we have to tell it that we want to go over the whole entire string. Down below we have the Ruby code. Nice and simple, G-sub. Yeah, it could be kind of cryptic, but as programmers we know what that means. And we give it our regular expression. Literals are in those two backwards slashes, and then the character to replace it with. So again, nice and concise. So how can we do Ruby today? Well, you can use this product called Ruby Motion. It lets you write iOS and Mac apps. Ruby Motion it came from the Ruby Cocoa project, which was originally a project to write Mac applications with Ruby. That became the Mac Ruby project, which was officially sponsored by Apple. They even had a an employee dedicated full-time to that named Laurent Sansonetti. And a couple of years ago, Apple decided that they no longer wanted to support Mac Ruby. So they gave Laurent the choice, basically he had to take a new position at the company. Rather than do that, Laurent decided to leave Apple, and he started his own company, HitByte, and they created RubyMotion. They first started with iOS, and then I think last year they added the ability to create OS X applications as well. So the nice thing about RubyMotion is it's built on top of the Objective-C runtime. So basically it's a sister language of Objective-C. There's no bridging that has to occur. Ruby strings are NS mutable strings. Ruby arrays are NS mutable arrays, and on and on. Everything you can do in Objective-C, you can do in RubyMotion. In addition, Ruby has gone native with RubyMotion. It's fully compiled. It's not an interpreted language anymore. It's compiled to native code on the Mac or on iOS with an LLVM compiler. And because it's compiled, there's a few things that are different from the normal Ruby language. For example, you cannot do require statements anywhere. You can only do that in your rake file, basically, and we'll talk about that later. And there's no eval statement. Otherwise, you'd have to have a compiler in your compiler, which, of course, wouldn't work. And even RubyMotion is based on the Ruby 1.93 syntax, but they've also added keyword arguments to the language to make it more compatible with Objective-C selectors. So when you download, when you purchase RubyMotion, because it's not a commercial project, or I mean it is a commercial project, so you have to purchase it from them for $199. The build part is open source, so you can contribute to that, but the compiler and stuff is not. So when you do download it, you get basically a command line tool set. You get this motion command that lets you create a new project, activate your license, update the software and get support. And then there's a rake file for each project that gets created where you can create your archives, do builds, clean your project, create tags for your editor, run on the device or the simulator, run your tests, everything else that you would need to do that you typically do in Xcode. Including, you would use it comes with a command line debugger, an LLD debugger that you can also run on the command line. So I wanted to go over some differences between the two languages that you need to be aware of when you're doing RubyMotion programming. So one is keyword arguments, how they're used in Ruby. At the first line of code is an Objective-C method signature, where each parameter kind of has a name associated with it. In RubyMotion, you have the same thing, except you kind of include that parameter, that name, right into your arguments of your method that you're calling, with the where it's underlined there. Another thing is pointers. Ruby doesn't have pointers, but Objective-C does. So how do you handle that? Well, on the first line here, we have an Objective-C method signature that we might have on NS data to write that data to a file. You'll notice that the last parameter is an air parameter that is a pointer to an NS air pointer. The next line below that is the Ruby version of that, where of course we don't have any types in Ruby, but that last air parameter needs to be an NS air pointer. So the way you do that is RubyMotion introduces this new pointer object. And you'll see that pointer new call, and then the object is the type that pointer is going to point to. And in this case, it's a generic object. And then we pass that to the method. And then to dereference it, you just create it like an array and get the first element of the array, and that's the value of the pointer. The other thing is blocks. Now, Ruby blocks and Cocoa blocks are not quite the same. So if you want to call a method, an Objective-C method that takes a block from your Ruby code, you just basically have to pass to it what is known as a Ruby proc, and basically you just put lambda in front of your block and pass it in that way. If you are calling just Ruby code to other Ruby code, you don't have to worry about that. You can just do normal Ruby blocks. So like I said, RubyMotion is pretty much a command line tool set, and that means you can use any editor you want. Use Sublime. There's some good plugins in Sublime for code completion and such. VI or Emacs, those all have, people have written extensions for those editors. And then also RubyMine is a Ruby IDE from the guys that created IntelliJ that has full support for RubyMotion, including a built-in debugger. So I spent the last month or so creating a RubyMotion app just so I could feel what it's like and get to know it. I created an app called Pitching Radar. Pretty simple app, and basically the feeling, you've got Xcode versus this command line based tool set, your editor and a terminal, or RubyMine. And basically it's a trade-off between integration and freedom and speed. Xcode is well integrated, everything just works together, code completion's perfect, you got the documentation built in, all that. But it's monolithic, it can be slow at times, especially when they do a new release, it can be buggy. On the other side with RubyMotion, it just feels, at times it feels a little faster, more free because I can use any tool I want. When I compile, I just switch to my terminal, type rake, and the compiler's a lot faster because it doesn't have a lot of that integration that it has to do. So that's pretty much what it feels like. Where RubyMine is kind of in the middle, kind of a nice compromise where it's got some integration, but it's also using the rake and RubyMotion tools in the RubyMotion compiler. So to create an app, you just use the RubyMotion command motion create, and you give it the name of your app that you're creating. If you don't specify a template, it'll create an iOS app. It comes with a template for creating OS 10 apps, and you can create your own templates as well. So it's just like when Xcode and you say new project and you have to pick your project type. That's kind of what a template is, same purpose. Once you type that command, it creates a bunch of files and directories for you. So it creates a directory for your application, and then it creates a git ignore file. It creates a gem file. You can use Ruby gems. It uses Bundler to help manage those. We'll talk about that later. It creates a rake file, which you use to manage your project and build and all that. It creates an app folder, which is where you're going to put all your source code, and it creates a default app delegate. It creates a default resources directory, and that's where you're going to put all your images and storyboards and nib files that will get copied into your application bundle. And then it creates a spec directory, and a spec is a test basically, and it creates a default test, and we'll talk about that a little later. So first of all, the first way to bring in code from external sources is gems. Gems are very popular in the Ruby community. But you can't just use any Ruby gem. You have to use gems that are specific to RubyMotion because of the require and eval restrictions that we talked about earlier. And the way you manage your gems is you use Bundler. Basically, you create a gem file, you list all the gems you're using, and then you type bundle install, and it downloads all those files and makes sure it downloads the dependencies as well. If you check out RubyMotionWrappers.com, you can see a bunch of popular gems for RubyMotion. So one of the most popular gems are these four. Bubble Wrap is kind of a general wrapper around all kinds of parts of Cocoatouch. It just makes things a little easier to use, shorter methods, a little more Ruby-like. It adds places to use blocks where Cocoa doesn't provide them, things like that. Joybox is a framework for writing games. So if you write games, you probably like this one a lot. It provides a wrapper around Cocos 2D and Box 2D, a higher level wrapper around those. Cocos 2D is a framework for writing 2D games, and Box 2D is a physics engine. So combine those two and you have a pretty fun framework for writing games. ProMotion is you can think of ProMotion as kind of like Rails for iOS development. It provides a DSL for writing iOS apps in a more Ruby kind of way. That's pretty popular. And Teacup is a way to provide style sheets to create your user interfaces and style them and whatnot. The Ruby guys come from a community where they're creating a lot of web apps, so they've come up writing HTML and CSS and creating their UIs by hand. So they've created a lot of tools to help create UIs by hand. So Teacup is one of the ways they do that. It's a DSL basically for creating style sheet-like things for iOS. So I'm an old-time Cocoa guy, and I love Interface Builder. And you can still do that with Ruby Motion with the IB gem. So here's an example. Extend IB. IB gem creates a module called IB, and when you say extend IB, it brings in that code. So you can declare an outlet. So there we're declaring an outlet called Go Button, and its type is UI button. And then down below that, button tapped is just an action. So what you do that, and then you just type rake IB open, and it's going to open Xcode. It's going to create an Xcode project behind the scenes, open Interface Builder, and then you can create your outlets, tie everything up together, and I'll show you how that works later. And yet another way to bring in some code is to use Cocoapods. So you add motion Cocoapods to your gem file, and then in your rake file, you have this app setup block, and then somewhere in there you create this app pods block, and you just list the pods you want to use. So pretty simple. And then you run rake, and it'll go and download all those Cocoapods, any dependencies they depend on, and compile them and everything else. If you're not familiar with Cocoapods, I recommend Aaron London's talk, which is after this one, and he's going to go into a lot more depth into Cocoapods and how you use them. And you can check out cocoapods.org also as well. And finally, the last way to bring in code, third-party code, is you can put any Objective-C code you want into your projects. You can freely mix Ruby Motion code and Objective-C code. You can even create static libraries in Ruby Motion and put them into your Objective-C projects. So the way you bring in that code is you basically copy it into a directory under you create a vendor called vendor into your app project, and then put that code in there. So for example here, I'm using the ChimpKit library. They don't have a Cocopod for some reason. So you download that library, put it in that folder. So here with that vendor project statement, we're telling it where that code is. The static argument is telling us whether it's an Xcode project or just code. Here it's just static, just means it's code. And then C flags are any additional C flags that I want to pass when it compiles it. So in this case, I want to say use arc. And then there, that last line, resource dirs, I'm telling it to include ChimpKit to any nibs or any resources in that ChimpKit to nibs folder into my resource directory, so that when you build it, it'll copy those into the application bundle as well. So we've got our app built. We need to do some debugging. As I said, RubyMine has a full-fledged debugger built into it. You can also do it from the command line with rake debug equals 1, and that will use an LLD debugger. In addition, when you run the simulator, your terminal window is still up, but you have a full-fledged REPL, so you can type any Ruby expressions you want into that command. And it also has a neat feature where you can click on stuff in your UI, and that becomes the target of your commands in the REPL. So you can even change that stuff at runtime and interrogate it at runtime. And we'll see that in the demo later. So this slide, I saw this in a Ruby presentation. I got a kick out of this slide, so I had to throw it in. The Ruby community loves their tests. They've created lots of tools to do testing, where in the Objective-C community it's not so much, but that's changing. Ruby Motion has full support for testing though, and it has a framework built in called Bacon. It's based on the Mac Bacon framework, which is an RSpec clone, if you're familiar with RSpec. So basically, you just type regspec. It's going to run all this tests in that regspec directory. Here's an example of an example tech spec that gets created for you automatically when you do the motion create command. That described line is really just kind of documentation of what this whole spec is about. The before do block is code that's going to be executed before every test. So there we're just getting a pointer to our application object. And then the it statement is, again, more documentation. This is a particular test case that we're going to do here. We're going to test that our application only has one window. And then in that block, you have the code that actually executes that test. And we're just verifying that the application has one window. So you can also do even more tests. As well as those simple unit tests, you can also do a form of UI automation testing. If you're familiar with that, Apple provides a tool to do that with you have to use JavaScript. With RubyMotion, you can use Ruby to do it. You just add this tests to your spec. You would say like test button view controller, and now you can write code that tests that view controller. If it's in a storyboard, you have to include your storyboard ID. Jonathan just talked about tests earlier upstairs. He's done a great presentation on the past on UI automation, and he's written a book on it. So if you want to know more about that, check out his book. Also, the RubyMotion.com site, they have a developer center with a lot of good articles, and one of the articles is on testing, and they go a lot more into the automation tests. You can do things like tell it to rotate your device, do acceleration, shake the device, do all kinds of gestures, taps, whatever, and then write code to verify that your UI did the right thing in response. So once we've got it tested, we want to do a beta test. RubyMotion has support for TestFlight. Just bring in the motion TestFlight gem, put that in your gem file, copy in the TestFlight library into a vendor directory, and then make these changes to your rake file. So you require the gem, you tell it where the SDK is, you tell it what your tokens are, you tell it your distribution list, and then you just type rake TestFlight with notes about what's changed in this release or whatever. It'll build everything, make a package, and upload it to TestFlight. Now, given all Xcode's integration, it does not do anything like that. So that's one example of having an open tool set like this, and users can extend it and do things like that. All right, so now we've got a beta test. We think our application is ready to go. We want to distribute it. Typically, you want to have different settings when you're doing a release build for the store. So you add an app release block to your rig file and give it, like, for example, a new provisioning profile. That's a common thing you're going to want to do. And then you just type rake archive distribution. It'll compile everything, create an IPA file, and then you can use Application Loader, which is an application that comes with Xcode, to upload that to iTunes Connect, and you're good to go. So it's not too hard, and it works pretty well. And Laurent is always on top of things. Even with iOS 7 betas, within a couple days, RubyMotion was updated to support it, so he's really on top of things. All right, so let's do a little demo. I put the code up here on GitHub if you want to get a copy of it. I'll come back to that side too later. Okay, good. All right. So let's just I'm going to type rake to show you this application here. It's going to take a little time to build. You can ignore that. That's something to do with Mavericks. Doesn't seem to affect anything. So you're seeing it's building my pods. It's created the pod library. Now it's linking. I'm compiling my storyboard. Sometimes it's fast, sometimes it's slow. There we go. Now it's copying all the resources into the application bundle, creating our IPA, and now it's launching it on the simulator. We still have to use the Xcode as simulator, so that has its own issues. It should come up here any second now. All right, there we go. So this is just a simple app to demonstrate how you do certain things with RubyMotion. We've got a navigation controller with the table view in here. Each one of these rows, when I click on it, will go to another view controller where I demonstrate certain things. Over here is our terminal with our REPL, so I can type any Ruby expression I want. And you'll notice that self is kind of pointing this main object, which I think is the REPL itself. And I can come over here and hold down the command key, and now you see that it highlights in red these UI elements. The reason it's off, as you can see in the terminal, that it doesn't quite work with Retina unless it's in 50% scale. That's not too big of a deal. So if I tap this guy, now you look back in the REPL, you notice it's changed to a label, which is actually the thing we clicked on. So we type self, it's label. We can say what's the text, it's nib, and we can even say self.text equals nib2, and you can see it's changed in our UI right there. So that's pretty useful. So let's look at how we did this. First of all, here's the rake file that it created. This is just boilerplate, bringing in the RubyMotion utilities and stuff. Here we're saying we're using the iOS template that's created for you as well. Most of this is created for you. Here we're using bundler. We're saying bring in the bundler stuff for our gems. And here's where we configure our application. Everything you do in Xcode, your Xcode where your project settings are, your info plist, that would be in here in the rake file in this section. So here we're setting our application name to be slopes motion. Here we're saying that when the app is on the device, we want the display name to just say slopes, because slopes motion is a little too big. And in here we're saying that our main storyboard file that it's going to launch is called main storyboard. And then we're going to use a couple pods. One is called Rapture XML. Now again, these are written in Objective-C. This is an XML parser, and progress head is a progress indicator. That's pretty popular.
So there's no pod file of these, correct?
Right. This is basically your pod file right here,
Okay.
and they've recently changed it so that when I did this, when you typed rake, that just when you built it, it would download the Cocoapods and then build them. They're now going to separate that into a separate process, so you do it like the traditional Cocoapods process where you say rake pod install, and then it does it. So, and now here's our gem file. We always bring in the rake gem. That gets created for you. We're going to say we're using the Motion Cocoapods gem. We're going to use the Bubble Wrap gem. We're going to use the NanoStore gem, which is a NoSQL database written in Objective-C. We're going to use our interface builder gem, and then we're going to use the teacup gem to show that. Here's our app delegate. This is pretty much created for you as it is right now. I'm not really doing anything in the app delegate. I added this adder accessor to add an outlet for the application's window. Let's get rid of some of these files. So here's our first view controller. Let me show you the storyboard. We're going to exit our simulator here. We just type rake IB open. Brings up Xcode with our storyboard here. And here's our navigation controller. Here's that first table view controller. And so each one of these rows leads to a view controller. And basically they're just shells to show how to do certain things. So I don't have to write all the code to do all these transitions and whatnot. So if this first view controller, the welcome view controller, is to show how you can do everything in storyboards without having to write any code, the standard stuff. So we've got the welcome view controller. If we click on it, we can see, let me change this. All right. Here you can see that we've set the class of the view controller to welcome view controller, which we've declared in Ruby. And we've set an outlet to our label, which is down here in our view. So that's just like how you normally use Xcode or interface builder. And when I tap on this button here, it's going to invoke the segue to bring up this little modal view, which is also one of our, actually I didn't have to write this controller because it just really doesn't do anything. That's not, it basically just, when I hit the done button, it's going to unwind. So it invokes the unwind sequence, that the segue that they added in iOS 6, which that ends up calling code back in my welcome view controller. So let's just show the app and see what it's doing there. So I tap on welcome. We've got our button. Let's see, as our label off screen. Let's change our scale. So there's our label down below here. We tap our button here, our modal view comes up. We tap done, it comes back, and we've changed our label to and you're back. So let's see how we did that in the code. Why isn't my thing changing? So here's our welcome view controller. We just declare it as a subclass of UI view controller. We bring in the IB gem. We declare an outlet of type UI label called label, and you saw that connected in Interface Builder. And then here's our unwind method that gets called. And we just set the text of the label to and you're back. So let's look at the next one. Go back to our menu. Nib, we tap on nib. This is to show that you can bring in external nibs and basically do the same thing as we did before. So we've got a label down here. We've got a button that says nib me. It's going to bring in a modal nib that has just a simple view controller. We hit done, it goes away. Our label has changed colors, basically. So the way we did that, again, here's our view controller, that nib view controller. We declared its class to be nib view controller. We've hooked up the label outlet. That's pretty much all we had to do in Interface Builder. And here's our nib view controller. Again, it's just a view controller. We bring in the IB gem. We declared our outlet. And then here's our show nib method. I didn't show that connected, but that button is connected to this method. And we create by hand a modal nib view controller object or class, and then we present it, and then we change the label to red. So it's actually red before it gets presented, and then it comes back and you can see it. And here's the modal nib view controller we presented. all it does is implement that done method that gets invoked, which then dismisses the controller. So the next part is to show how you would create a UI by hand, like the Ruby guys like to do. So it's going to be just standard Cocoa, but we're using Ruby to do it. So we click on that. We're presented with a label and a text field for entering a name, and so it's automatically going to capitalize the words. There's no text correction. It's got a clear button. When we hit return, it automatically dismisses the keyboard. That's all it does. So this is what that code looks like. We've got our viewDid method, or viewDid load method. You'll see that to call super in Ruby, you just have to say super. You don't have to repeat the method call and all the arguments. That's pretty nice. We invoke our setup form method that's going to create this UI. Let's get rid of this a little bit. So here we're creating our label. One thing you'll notice is that our frame is just an array of points rather than invoking chrect or cgMakeRect, and then the points itself is just an array of values. Those are the top left width height parameters of your frame, and everything else is just pretty much standard Objective-C or like Objective-C. We're setting our text, setting the font, we tell it the size to fit, add it to the view. Here we're creating the label for the text field based upon the labels frame to set it side by side. Then we create it, set its border, give it a delegate, make ourselves the delegate, tell it to automatically enable the return key and other keyboard traits, capitalize the words, no autocorrection, add a clear view button, and add to the subview. Here's our delegate method that automatically dismisses the keyboard when they hit return. And that's it. That's how you create your UI by hand using the normal Objective-C method, but with Ruby. So next, let's see how the Ruby guys like to do this with Teacup. So the Teacup view is exactly the same thing. We've got our name, our label, and our text field that behaves exactly the same way. We hit return, it dismisses the keyboard. And the way we do that is here's our Teacup controller. So first of all, you declare that you're going to use a style sheet called Teacup view. And then we're going to have a layout named root. And to that layout, we will add a label called label. So a view of type UI label called label. And then a view of UI text field called name field, setting its delegate to ourselves. And here's that same method we had in the previous class to dismiss the keyboard. And then here, we are declaring a style sheet that we referred to up above. And its name is Teacup view, as we specify here. And so here we're going to style that label up above. And we give it a frame, a text color, a text, a font. And you'll notice that these are pretty much the same as the Objective-C code. These values are the same Objective-C properties. So any property you could set, as long as it's an Objective-C property in Cocoa. And here we're styling the name field, same way. Now I don't have to style just instances. I could say style UI label, so all labels would be styled that way. I can even inherit style, so I could say that this label inherits from a general UI label style. So it's pretty neat. I can put these style sheet. I don't have to put the style sheet in this file. I could put it in any file. In fact, I could put all my style sheets in one file, just like you normally do when you're using style sheets. It also supports other style sheet simulators for iOS like Nui and Pixate that have come out. And there's also a gem called SugarCube that makes this even more like CSS. So for example, for text color here, instead of saying UI color, black color, I could just say black. So you can get really close to style sheets. That's pretty interesting. Yeah? It's just as compatible with Objective-C. You can set the same voiceover properties, set them in an interface builder, same stuff.
Because some of these classes you get from Apple, you can walk and implement things, and they may be not voiceover, and you can't access.
Uh-huh.
So I'm like, is this using all the standard underlying window behavior?
Yeah, it's using the same Objective-C frameworks, Cocoa frameworks, it's UI kit that does that stuff, accessibility, same stuff.
Ruby occasionally wanders off and does its own thing.
Well, this is built on top of the Objective-C runtime, so it's all the same frameworks.
Can you link your style sheets to a URL?
I'm not sure. I mean, you might try that. You might be able to download it from the network at runtime. That would probably work. Might work. I'm not sure. Apple might reject you. I don't know. Yeah.
How good is Ruby in its type inference, like the frame property there? You're setting a CG rect, but it's possible that could represent a different struct.
Well, Ruby Motion is they've added this ability to specify CG recs as an array of points like this. So that's just another. It knows the Ruby Motion compiler knows that is a CG rect.
So if you were to specify something like a CG size or a CG point, how would it differentiate between those two?
I would suspect that because a CG size is only going to have 2 points, the compiler would report an error.
I'm sorry, a CG size and a CG point.
Uh-huh.
So they both have just 2 floats.
It means like distinguishing between a CG size and.
Oh, it depends on what method you're calling, I guess. And it would probably, if you're trying to pass a CG size into a point, it'd probably just assume you're passing a point.
So it does some kind of inference based on the expected type of the.
Arguments, yeah, I would think so. Something you could try with the compiler and see what it does. All right, so one last view controller that we have here is Bubble Wrap and Nano Store. And so what this view is going to do is it's going to go up to my 37 Signals backpack account. It's going to read in all my backpack pages, or at least their titles and such, and display them in a table view. So it's going to connect to the network and download those. And then it's going to save them locally in a NanoStore database. So this is going to show you kind of the power of Ruby that you can get. So there it goes, brings up the HUD that we brought in. Here's our list of pages. And it saved them locally. So the way that happens is here's our Bubble Wrap view controller. Again, we've got the IB gem. We've declared an outlet to our table view. We're creating an empty array for our pages. That's just a normal Ruby array, which under the covers is an NS mutable array. When our view appears, we bring up our progress HUD. And then here's a bubble wrap call that we're using to call to the network. So we're saying post to this URL, and we're passing the arguments in payload, basically my API token. If you've used NS URL connection, you know that this is a lot more complicated, so bubble wrap really makes this nice and easy to do. And it's going to call, we give it a block that it's going to call when we get a response back. That response in this case is just some XML. So we create our XML parser, giving it that XML. And then we iterate through all the pages elements, all the page elements inside the pages elements. So that's a little XPath that we pass to our parser. And then for each one of those, we give it a block. Now, see, we're passing Objective-C, so I have to use lambda in front of my block. And it's going to give us each element here. And then here's where we're getting a little tricky Ruby. I create an array with these symbols, which are basically the properties that I'm interested in. For each one of those, we create an array that contains the name of that property and its value from the XML. And we're going to put all that into a dictionary called attributes. And then we create an instance of this backpack page object, passing it those attributes we got from the XML, and then adding it to our array. So this backpack page object is this class, and I'm showing a little Ruby metaprogramming here. Here we've just declared the properties that this guy's going to have as symbols. Then we iterate through each one of those, and we tell Ruby that we want to create an instance variable, though, with getters and setters for that. So that's what this block of code does.
Just the attribute. Is that a Ruby?
Yeah, that's a Ruby keyword to create an attribute, declare an attribute. And then in our constructor, we were passed that attributes hash. We go through each one, taking its key and value, and we send a message. We send the setter to that ourselves. If the property is one we're interested in, it's one of those members we declared above, and we set it to the value that we got from our hash. So pretty generic code. If you want to add a new attribute, you just put it in your array up here. That's kind of nice. And then here's just a simple method to convert our page to a string for debugging or whatever. So going back here, so we've gotten back from our network, we've processed our XML pages, we dismiss our HUD, and we tell the table view to reload, and then we're going to save our pages locally. So the way we do that is we create a shared a store with NanoStore. Notice here that this is a bubble wraps call to get the documents path where you're in your app sandbox to create your files. That's a lot easier than the Objective-C call where you have to call NS search directories or whatever it's called and all those parameters and everything else. I have to look it up every time. And then we create a transaction and tell each page to save itself to the database and catch any exceptions if they occur. And then we have our table store, data source methods. The number of rows is just the length of the array. Here we have our standard cell creation for our table use cells. This or begin is kind of a little Ruby convention. So if DQ reusable cell with identifier returns nil, it's going to execute this little block that just creates the cell and returns it. And then we configure our cell with the title of the page. So that's it. All right, that's my demo. Did everyone get this URL down that wanted to? All right, any questions? Yeah.
So I didn't get to see you do proof of sublime text as any auto completion.
It does. There is a package called Ruby Motion Builder that lets you do builds in here and everything else. Let's just see. It does some kind of completion. Sometimes it works. Sometimes it doesn't. You have to run rake C tags to build all your tags. That helps it find the completions and stuff like that.
Do you worry at all that, like, I mean, RubyMotion's kind of set an interesting precedent, charging $200 for a tool that otherwise you could do that sort of development for free. Do you worry that that'll kind of like trickle down? I was looking at Joybox, and honestly, at first glance, I thought it was going to be something else you'd have to pay for. And like, I guess I just kind of worry about these tools that are building on top of tools that cost money. We just create this endless tunnel of something that you need to purchase to get anything done.
I don't worry about that because when RubyMotion was created, the RubyMotion community exploded. It's grown like crazy. And all the tools they've created are all open source. The only thing that's commercial is the compiler itself. So it doesn't seem to be an issue. Any other questions?
So, I mean, I know the compiler's closed source, but I guess, so like for me, with any tool like this, the immediate worry is that the tool gets behind the source product, and then the tool is something you can't use to stay up to date and stay up to date with the tool. It seems like because of the particular approach that they've taken, some of the issues that lead to that problem would be ameliorated.
Mm-hmm.
So I guess either you have to know more about compiler, but it seems like as API is added, is it the case that automatically RubyMotion can access that API?
Pretty much. I mean, I'm not sure how it's implemented, but
Right.
Laurent fixes any problems that occur with the compiler pretty fast. With iOS 7 betas, he was right on top of it. The build tools are open source, so those can be fixed by just about anybody, but HipByte is on top of those. And the way it's architected, it automatically picks up new API. There's some kind of data file in there that they just have to change, and then the compiler will automatically do something with it. I'm not sure exactly how it works. But so far there haven't been any issues like that. At the most, you're waiting a couple days to resolve issues.
Is there any way to see the equivalent Objective-C that it produces, if you're curious about that?
Well, it's not producing Objective-C. It's just going right to native code.
Oh, right, it goes straight to cloud layer.
Yeah.
Okay. Are there gens that produce equivalent Objective-C?
I don't think so.
Okay. And if you wanted to inject, so I know that like you could like add a class of Objective-C into your project, but if you wanted, is there a way to like inject Objective-C for some particular part of some particular method?
You want to put Objective-C into the RubyMotion project?
Not literally in the same file, I imagine that's not possible, but some way to reference some other file.
I'm not
Probably
sure
not.
what
I
you're
don't know.
getting
I'm
at.
just trying to think of things
Okay.
that might come up in my brain later.
Anything you can do in Objective-C, you could do with RubyMotion. So you could, well, I don't know about mock injection and stuff like that. Maybe not. I don't know.
I'm asking crazy questions.
All right, so that's my presentation. I'm available for hire. If you need me full-time contract or you want some training on RubyMotion, I'm available. You can contact me at these places. So thank you very much.